So this is how association rules are generated based on a set of frequent item sets. There have been also some efforts in formalizing the task of association rule in a with a probabilistic interpretation and framework. So this task was actually proposed by Brin and his co-workers in 1997, in which an association rule are A implies C, in which A is called antecedent and C the consequent of the rule, is expressed as a distribution of A and C in the finite space of the data set D. So we're going to estimate the probabilities in a space limited by the data set D. So the sets A and C are seen as two probabilistic events, to which you could calculate the probability P of A and P of C that stand for the probabilities that event A and event C happen respectively. So the probability in this case, as I said, is estimated by the frequency of A and C respectively in the data set D. So recall the support of a rule A implies C is the support of observing the items in A and the items in C. So this is the support of A union C. In the probabilistic framework, we talk about the probability of observing the event A and observing the event C happening. Likewise, the confidence of A implies C is written as a probability of the events. In this case, the probability of observing the event C given that the event A happened, which would be just simply the conditional probability of C given A. So it's going to be the probability of A intersect C, or A and C, divided by the probability of A. There has been also some efforts in devising other kinds of evaluation measures beyond the support and confidence. Why beyond the support and confidence? Because this pair has some limitations, as we can see in this example, inspired from a paper from Brin et al. In 1997. Okay, so suppose we have a data set that we summarize in this confusion matrix, right? Confusion matrix. This summarizes the frequency observed for the customers buying tea and coffee. So for example, this number here, 20 of the customer bought both tea and coffee, 50 of the customer bought tea but didn't buy coffee, 20 of the customer didn't buy tea but bought coffee, and 5 customers didn't buy coffee nor tea. We're going to express the marginals in terms of the sum of the rows and the sum of the columns. The sum of the rows express the number of people who bought tea, the number of people who didn't buy tea. The columns will be the number of people who bought coffee and the number of people who did not buy coffee. The total number of instances or examples would be 100 in this case, which is the sum of the marginals. All right, so if we are interested in the rule T implies coffee. This association rule is by the support and confidence framework is interesting because the support of the rule would be equal to 20%. So you could observe that we have 20%, 20 over 100, which represent 20% of customers who bought tea also bought coffee. This is the support of the appearance of both tea and coffee in the data set D. The confidence would express the conditional probability of buying coffee given that the customer bought tea, and the confidence, if you apply the measure, the formula of confidence, which would be the support of tea and coffee of 20% divided by the support of tea, will represent 80%. If you put the minimum support of say 20% and a minimum confidence of say 60%, then this rule here would be deemed as a strong association rule. Okay, it is a strong one. However, it's probably not an interesting one. And why is that? Simply because it's a misleading rule. Observe that the support of coffee by itself is 90%. This actually introduces a big bias in that the confidence cannot detect. 90% of the data is actually about customers who bought coffee. This will provide lots of weight to coffee, and this cannot be detected by the confidence measure alone. Because simply actually the confidence of a rule in this case would be the confidence of T implies coffee, which is equal to the support of T and coffee divided by the support of T, would simply actually ignore the support of coffee, which is actually a very high support of 90%. Okay, so that's where the limitation of the pair support confidence comes from. Therefore, there were some efforts in devising other evaluation measures, such as the interest, also known as the lift. The interest of a rule antecedent implies consequent is the probability of observing both the antecedent and the consequent, divided this time by the probability of A times the probability of C. So you could see that in this case we are factoring in the probability of the consequent, which would be the coffee in our case. This probability is estimated by the support that we observe in the data set D, which would be the support of having the items in A union C divided by the support of A times the support of C. Depending on the value of interest, if the interest is 1, we deem the relationship between A and C as 2 independent events, and then there is no relationship between them. If the interest is bigger than 1, then A and C are positively correlated or dependent. And if the interest is less than 1, then which means that A and C are negatively correlated or dependent. Okay, so we could write other forms of writing the interest of A and C. If we have the confidence and the support, we could simply turn that into using the ratio between the confidence of the rule divided by the support of C, which has been calculated in the previous step of mining frequent patterns. So let's take again our example of tea and coffee. Besides the confidence and the support of the rule, we can calculate the interest of the rule T implies coffee by plugging in the numbers in the formula that we just defined. The interest of T implies coffee will be in this case equal to 0.89, which is less than 1. So by this interest, we're going to deem this rule as interesting, but the tea and coffee items are actually negatively dependent. So we could also think of generating all possible rules from this confusion matrix, which would be T implies coffee, T implies not coffee, coffee implies not tea, and not coffee implies not tea. We could calculate the interest measure, and we would see that actually there is a strong relationship between tea and not coffee, and between coffee and not tea. So it makes sense that maybe coffee drinkers are not always tea drinkers, and vice versa. Okay, so this gives a better picture about the strength of the rule than the pair support and confidence alone.